Okay, Assalamualaikum warahmatullahi wabarakatuh. So in this video, I'm gonna show you the data processing tutorial of the skill reinforcement test. As you can see on the Excel that I have shared to you before, there are several data you need to input. The data are from the practicum you've done last week. First data is diameter. The diameter we're using is the diameter from the smaller area. Input the number from your module, then you have to convert the number from the unit of centimeter to millimeter by multiplying the number with the number of 10. So you can get the number in millimeter. And then the second thing to do is to input the cross-sectional area. The cross-sectional area that we have determined before is using the formula of V diameter square per divided 4. If you have the data of cross-sectional area in centimeter square, you have to convert the data to millimeter square by multiplying the number with 100. So you can get this. Click the number and multiplying with 100. But if the result that you got is in the unit of millimeter square, then you can convert it to centimeter square by dividing the result by the number of 100. Okay. And then the next thing is to determine the initial length of the strainometer. You can get the result from the measurement of the original gauge length, L or LO, as what you've calculated before with the formula of 5.64 square root AO. The AO that we use is the data of cross-sectional area. The initial length of the extensiometer is the original gauge length. And you can do the same to this data, convert the data from centimeter to millimeter by multiplying the centimeter number by the number of 10. Next, let's get to the stress strain testing result. The first thing you have to do is to input the load data based on your own group's testing result. For example, I have this testing result on my Excel, and you have to input based on your own group's testing result. And then you have to convert the unit of kilogram force into Newton by multiplying the number of kilogram force load with the number of 9.81 and then click enter. And click the edge of the cell, bring it down into the whole column to update automatically with the same formula. And then you have to mark the data or give the note to those data that you got from manual divider or pembacaan jangka, manual divider reading, because the formula start from here will be different from the formula from the strainometer reading. This is strainometer reading and this is the manual divider reading. And the formula for determining the deformation will be different. But if you have more data, you can just adjust your cell by clicking the edge of the cell and bring it down to add more tables. Or you can delete the cell by blocking the whole cell and click the right mouse and delete. And next, for the extensiometer, you can input the data based on your extensiometer extensiometer reading from your module. And I have these numbers as my data. And then for the deformation or delta L real, you're using the formula of sternometer reading multiplied by 10 to the power of minus 2. So you're clicking the sternometer or extensiometer reading and multiplied by 10 to the power of minus 2. And then click enter. But this is important that this formula is only applied for the sternometer reading. So you only can drag the table down until the end of the sternometer reading. This, okay? Next, the deformation using the manual divider. So you can see there's distance from each edge of manual divider based on your data. For example, this is my manual divider. This is manual divider, and the distance of manual divider based on my own data. This distance is I'm sorry. My manual divider distance is 52 millimeters. This 52 millimeter is obviously the distance after your specimen is extended. For example, I'll give this distance with the code L1. Meanwhile, the this delta L or deformation from manual divider reading is the difference or selisih from the LO, this LO, and the distance of the extended mark, the L1. So how to get the delta L from manual divider reading? It is using the formula of L1 minus LO in millimeter unit. So if we have to draw the example, this is the L1. Let's make it thick so that it can be seen clearer. And this is LO. And this is LO. So the difference from the L1 minus LO will be the delta L or the distance. L1 minus LO. So this length is the distance of the delta L, or we can say that is the deformation. So how to get the deformation on the cell is by clicking the L1 minus LO. LO in millimeter, don't forget. And then you have to lock the cell of LO number by clicking the button of F4 until the symbol of dollar is showing. So when you drag the cell down to automatically update the formula, LO cell won't be changed. Click enter and then drag the cell down to automatically update. And then for the strain, To determine this strain in percent absolutely is by the formula of deformation divided by LO. So the formula of deformation divided by LO. And don't forget to lock the cell by clicking the button of F4 until the symbol of dollar is showing. And then click enter, and you can click the edge of the cell to automatically update the whole column, or just drag the cell down. So the whole column will be updated with the same formula. And last, before you determine the stress, you need to know the important concept, or you probably got this material in the class, the formula of stress. You can see the formula of stress here, where the stress is equal, the force is divided by cross-sectional area. The force is in Newton, and the cross-sectional area is in meter squared or millimeter squared. The unit of Newton per millimeter squared is equal to megapascal or MPa. Since the cell is in MPa, so we're using the millimeter on the formula. So to determine the stress, we'll be using the load in Newton, and divided by cross-sectional area in, don't forget, millimeter squared. And then you have to lock the cell of cross-sectional area by clicking F4 so that the data won't be changed for the cross-sectional area, and then click enter. And you can drag the cell down or click the edge of the cell twice so that the whole column will be updated as well. Okay.